Hello, and this is the symposium video for my reed relay, which I figured the dynamics for on the poster that was submitted. The final presentation is this apparatus here, which can be viewed from the side. Ordinary relays only switch at speeds as high as 30 times per second, and this one, although a more convoluted design, can switch at speeds as high as 500. The research documented presents alternative methods which may enable faster speeds beyond this. The central thesis of my project is based around the reed inside the glass tube, which obeys Newton's second law as stated here. When you look inside the reed, you see that it has a contact armature which moves between 2 points, one of which it's normally at. This one is called normally closed and this one normally open. The trick is that when you have a magnetic force here, north, south, it behaves as if there's a single pole here, we'll call it north, and attracts it this way. Of course, we can figure the mass of the reed. The difficulty is that this force is nonlinear, and the force of a magnet is actually equal to the magnetic constant times the product of the two poles divided by the distance squared. And since acceleration is related to distance, the problem can become difficult to solve. But this differential equation here was solved, and it turns out that the action of the armature can be sped up if you use less mass or greater force. I will now show what was accomplished. This coil here, which you can see from the back, is the control electromagnet. It is powerful more so than this one, which is further away. Inside, as I've shown in the figures, is the reed armature and contacts. This one pulls it down towards the normally open, and this one helps it restore itself to the normally closed. As we turn on the field, you can see on the screen that it generates pulses, and as you can tell, you can hear the higher pitch. It generates them significantly faster than any ordinary mechanical relay on account of the large forces involved and the tiny dimensions. The relay here has only 137 micrometers separating the two contacts, which is what distinguishes the reed relay from alternative mechanical relays. The work is documented in my research paper on the subject, explaining the dynamics of the force and momentum and finally the trajectory of the reed. As can be shown, a knowledge thorough of the dynamics of a system can be exploited to achieve higher speeds and superior performance, which was the central thesis of my work.